Welcome back. We will be doing two examples in this video. Here's the first one. Let's say that r of t is a vector function, and here the first component of r of t is t squared minus 2t. The second component is 1 plus 3t, and the third is t cubed over 3 plus t squared over 2. And what we want to do is we want to find the unit tangent vector t of t at t equals to 2. So in order to find the unit tangent vector, first we need to find, remember, the unit tangent vector is a unit vector in the direction of the derivative vector. So the derivative of r of t would be 2t minus 2 I plus the derivative of the second component here is 3 j plus the derivative of the third component would be 3t squared over 3, so that's t squared, and here I get t, so t squared plus t. So this is r prime of t, and then since we want to find the unit tangent vector at t equals to 2, let's look at r prime of 2. So that's going to be r prime of 2, so that's going to be 2 times 2 minus 2, which is 2. This is going to stay the same. 2 squared plus 2, that's going to be 6. So that's r prime of 2. So now we got the r prime of 2, that's the vector. So the unit tangent vector is a unit vector in the direction of this, in the direction of r prime of t, r prime of 2. So to find the unit vector in the direction of this vector, we need to find its length first. So the length of that is, the length of this vector would be the root of 2 squared plus 3 squared plus 6 squared, which is the same as 4 plus 9 plus 36, which would be 49. So root of 49 is 7. So the unit tangent vector t of 2 would be r prime of 2 divided by the length of r prime of 2, and so it is 1/7 of 2i plus 3j plus 6k, and so we see that t of 2 is 2/7 I plus 3/7 j plus 6/7 k. Okay, so that's the unit tangent vector at t equals to 2. Okay, so next example is the following. So we have a vector function r of t, and we are assuming that the length of this vector function is c for all t where c is a constant. Then we want to show that the derivative of r of t must be perpendicular to r of t. So remember, r of t is a vector, r prime of t is a vector, and we are saying if this equation holds, then the derivative of r is perpendicular to r. Okay, so how do we show this? Well, so let's start with the condition that we have. So let's suppose that the length of r of t is c, where c is a constant. We know that the length of a vector, okay, if the length is c, then the square of the length is also going to be c. Okay, so let me write that separately. So then the length of r of t squared would be c squared. But the square of the length of a vector is basically the dot product of r of t with r of t. Okay, so now we are going to take the derivative of both sides. So we take the derivative of r of t dot product with r of t, and the derivative of a constant squared would be 0. Now we apply the product rule here, so we can say that this is r prime of t dot product with r of t plus r of t dot product with r prime of t. But we know that the dot product is commutative, so the order of so if you look at the second term, the order of the two vectors doesn't matter, so the both of the terms are actually the same. So what we have then is 2 times r prime of t dot product with r of t is equal to 0. And so we see that r prime of t dot product with r of t should be 0, and therefore since the dot product of so if the dot product of two vectors is 0, then we know that they are perpendicular, so r prime of t is indeed perpendicular to r of t. Okay, so with that example, we are going to stop the video, and in the next video we will be looking at integrals of vector functions.